Hello, and today we're going to be solving radical equations. And I know what you've been thinking, Mr. Erb. We've seen expressions. When are you going to bring out the equations? And today is your lucky day, because by the end of this video, you should be able to solve equations containing radicals and identify extraneous solutions. And that may come in the next video, but that's okay. So, have out your notes and be ready for some math. A radical equation is an equation that contains a variable in a radicand. And if you remember, that means the stuff underneath the radical symbol. So examples include the square root of x minus 5 equals 3, and the square root of the quantity x minus 2 equals 1. To solve a radical equation, get the radical by itself on one side of the equation, then square both sides. The expression under the radical must be non-negative. And I talked about that a little bit in earlier videos, but really what that means is you can't have we can't take a square root of a negative number and have it be a real number. It actually turns out that that number is imaginary, and that's an actual mathematical concept and not just some crazy thing I'm saying. So let's try some problems out. So we have the square root of x plus 7 equals 16. And if I'm going to be trying out these problems, right, our first step here is to be, we have to rewrite this in our notes. And the first thing I'm going to do is I'm going to subtract 7 from both sides. So that means that the square root of x equals 9. And then to get rid of a square root, all we have to do there is square both sides, because to get rid of a square root, you square. So x would be equal to 81. And it's simple as that, right? It's not too complicated of a process. So let's try another one. So the next one we have is the square root of the quantity y minus 5 equals 7. So because I don't have anything to add or subtract there, my first step is going to just be to square both sides. Because the first thing I need to do, I can't add that 5 over yet because it's underneath the radical. It's in the radicand. So I have to deal with my powers before I move on. So squaring both sides leaves me with y minus 5 on the left side, and to the right I have 49. And that's just a one-step equation right there. All I have to do is add 5 to both sides, and I get y is equal to 54. And that's it. I'm done. So let us try the next one. Well, how about this? How about you try? Try these two problems. Pause the video here, and when you're done, come back and we'll check what you got. Okay, so you tried these problems out, and you realized that the first one should have been the second one should be k equals 100, and the first one should be a equals 5. If you got that, move on. If not, stick around. I'll explain. So this first one, our first step, on the one on the left, we have to square both sides because we have everything underneath the radical. We need to get the radicand by itself. So I square both sides. And that gives me 13a minus 1 equals 64. Then I add 1 to both sides, and that gives me 13a equals 65, which means that a, when I divide by 13 on both sides, a has to equal 5. And that's all she wrote there. The next one, the first step is actually to subtract 3 from both sides, which would give me negative square root of k equals negative 10. And then I can't just square both sides yet. I mean, I could actually, but what I'm going to first deal with is get rid of that coefficient. It's kind of good habit for us to get rid of that, just so that way we're not having to worry about it in the end. So that'd be square root of k equals 10, and then I square both sides, which leaves me with k equaling 100. And if you had actually just squared both sides there, you would have ended up with k equaling 100 too. So there necessarily you didn't have to get rid of it. So let's try some more problems out. What is the solution of the square root of the quantity 6t minus 5 and the square root of the quantity 3t plus 4? So having to try these problems out, all I have to do here is square both sides first. Because they both have radical symbols, to simplify it, I just have to square both sides. So that means 6t minus 5 is equal to 3t plus 4. And here you just have a two-step, well, three-step. You got an equation with variables on both sides. I add 5 to both sides. which means 6t equals 3t plus 9. That's a weird looking t there. And then I subtract 3t and get 3t equals 9, which means t equals 3. And if I want here, I can go back and double check. It's always good for us to go back and double check. And I'm going to say, I'll put that in there, and I'll say, is the square root of 6 times 3 minus 5 equal to the square root of 3 times 3 plus 4? Well, if I simplify that left side, I'll get the square root of 13 because it's 18 minus 5. And on the right side, I'll get the square root of 9 plus 4, which is 13. So I know that is the correct solution. All right, let's try one more before we let you try some yourself. So my first move here is square both of the sides. Again, because I have those radicals on both sides, my first move is to square both sides. So that will give me 2y plus 5 equals 6y minus 11. Then I subtract 2y from both sides because I want to have all of my y's on the side with the most y's. So that'll give me 5 equals 4y minus 11. I add 11 to both sides, which will give me 16 equals 4y. Therefore, y equals 4. That's all I have. And if I want to try to substitute that, that would be 8, the square root of 8 plus 5, which is 13 again, equals the square root of 24 minus 11, just plugging it back into this equation over there, which would be the square root of 13. So I know the square root of 13 equals 13, or the square root of 13, so I know that this is the correct solution. And again, if you are confused as to why it might work, why that square root, we talked about it earlier. Square root is really raising everything to the 1/2 power. So if I were to square both sides, really what I'm doing there is when you're squaring, you have to distribute that, and we multiply our powers together. So I distribute it only to right here, which would give me 2y plus 5 to the first, which would just be 2y plus 5. And that's why squaring both sides works. Let us have you try these next two problems. Okay, pause the video here and try it out. When you're done, come back and see the answers. So by now you've had time to watch these, and you will have noticed, or try to solve these, and you will have noticed that the first one says that m equals 5/2. The second one says s equals -2. If you got both of those solutions, move along, but if not, stick around, I'll explain. So first one is just pretty simple, and both of these really I'm just squaring both sides. But that will leave me with 3m plus 1 equals 7m minus 9. Therefore, 1 equals 4m minus 9. And I just subtracted 3m from both sides to get there. Next, I add 9 to both sides, which gives me 4m equals 10, which means m is equal to 10 divided by 4. But my answers always have to be simplified here. So m equals 5/2. And I'd rather you leave that as an improper fraction, because why do more work if you have to? Let's try the next one. Here, again, I'm squaring both sides, which gives me s plus 10 equals 6 minus s. From there, I add s to both sides. So 2s plus 10 equals 6. So therefore, I have to subtract 10 from both sides. Let me get rid of that garbage down there. 2s equals -4. So s equals -2. Anytime you kind of get a negative solution, you always want to really check to make sure that that's going to make your solution still work. Because if you were to end up with a negative underneath the radical, that would mean no solution. So I'm going to check that out. I'm going to say square root of -2 plus 10 equals the square root of 6 minus a -2. Simplifying that down would be the square root of 8, which we know equals 2 square roots of 2. And on the other side, we get the square root of 8, which is also 2 square roots of 2. So we know that that will be a solution. And we always want to check, because you will run into times where you don't have solutions. Thank you for watching the video. We're going to end it right here actually because the next video is going to go into extraneous solutions. So as always, make sure you're taking all the good notes and have a fantastic day. Thanks for watching.